here we go. Today's lesson is going to be about factoring. So this is factoring when we have a leading coefficient of understood 1. An understood leading coefficient of 1. How do we factor? What do we do? Now yesterday we learned how to do it when we had perfect squares. Well, these are perfect squares, but this one's minus. Did we have any yesterday that were negative? No. So we're going to have to look at another method. I call it reverse FOIL. You can call it the easy way because it's not hard. All we're going to do is we're going to take a trinomial like this and we're going to factor it into two binomials. Or we're going to try our best. Sometimes they're prime and they won't factor at all. Sometimes they just have a GCF. But sometimes we can factor them into two binomials. And the way you do that is you look at your last term and you ask yourself, what can I multiply to get negative 4? So what crosses your mind is positive 1 and negative 4, or negative 1 and positive 4, or positive 2 and negative 2. And saying negative 2 and positive 2 really is the same thing, right? Okay, so we ask ourselves, what can we multiply to get 4? Because I know when I multiply two binomials, these last two terms, when I multiply them, gives me that constant. But I also know that I add the middle terms. So you're asking yourself, what can I multiply to get negative 4 that I can add to get positive 3? Out of this list, what can I multiply to get negative 4 that I can add? Okay, yes, Max.
Negative 1 plus 4.
Negative 1 and positive 4. So this will break down to y minus 1 times y plus 4. Okay? Because y times y is y squared. Y times 4 is positive 4y. Negative 1 times y is negative 1y. And negative 1 times 4 is negative 4. What happens when I add these two?
3.
Yeah. So do you see why I said, okay, what do we multiply to get this? That we add to get that. What do we multiply to get negative 4? That we add to get positive 3. Now after we do 4 of these, I will accept questions. Okay? So let's take a look at the next one. Number 2. P squared minus 2p minus 24. We're going to take that same route. We're going to ask ourselves, what can I multiply to get 24 that I can, negative 24 that I can add to get negative 2. So I think about the factors of 24. I've got 1 and 24. I've got 2 and 12. I've got 3 and 8 and 4 and 6. Now obviously these would have to have opposite signs because I'm multiplying and getting a negative. So is there any of these that we could give opposite signs to? Okay, what do you think? Hold on. Question.
4 and negative 6.
4 and negative 6. Excellent. So we're going to change this to p plus 4 times p minus 6 because positive 4 times negative 6 is negative 24. And positive 4 plus negative 6 is negative 2p.
Wait.
Beautiful. Not yet.
No questions.
After the first 4, then we'll take questions. Okay, this one. What can I multiply to get 12 that I can add to get negative 7? Okay, you got it?
Negative 4 and negative 3.
Negative 4 and negative 3. We didn't even have to make a list. Negative 4 and negative 3. If I multiply those two, I get a positive 12. And if I add those two, I get a negative 7. Okay?
Can we do the floor and say that's like a U-try?
We have a whole page of U-tries.
Is it about to get
Okay.
a lot more hard?
All right, number 16.
Hard.
What can you multiply to get 16 that you can add to get 10? And this problem is going to look familiar. Okay, what do you think, Colin?
8 and 2.
8 and 2. M plus 2 times m plus 8.
Can you say 8 again?
No.
Irritated.
All right. So I gave you this problem yesterday because it looked like it was one of those perfect square trinomials because it had a perfect square and it had a perfect square. But I showed you when we doubled the product, we didn't get 10, we got 8. So this is how this trinomial factors. All right. Some of you have picked this up quickly and you're ready for some U-tries. Some of you still need my help. So I'm going to walk around while some of you fly through these, and I'm going to help those that need a little assistance. You multiply to get the last term, but you add to get the middle.
So that's just the answer?
Yeah, the 2 binomials. Yes, that's it.
Which one do you put in?
If you double this product and it doesn't give you that number, it doesn't.
No, negative 19. It's plus.
Double the product.
How was it there? Because that minus 31.
6 is
16 and 2 is 3 and 10. No.
6 is harder than 6 to do what you get.
I don't know if that is.
Oh,
That
he right. He right. No. Oh, he right. Wait,
I can guarantee you.
That is right. That is right. That is right. Yes, it is.
yeah, it is. Say it again.
Oh my gosh.
Say it again.
Number 7 is actually really easy. Oh. Yeah.
Sometimes the most obvious are the hardest to see, aren't they?
Add anything that equals. Oh.
That's this was hard.
It's actually not that bad.
If
You didn't say that before we started, I probably would have been
Which one?
I mean, I'm just being honest here.
Oh, we
Just
have
maybe
double
think
that.
6 times 5.
Those were. You're right. It's easy.
I'm done.
Yeah, this is really.
Can I go get a drink?
Sure.
Thank you.
Wait, I was not tired.
Okay, you've had enough time to do enough of them. Now, I just wrote this way so you can see multiplication is commutative, which means that 2 times 3 is the same as 3 times 2. We can switch the order of the binomials, and it doesn't make a difference. We just have to be really careful. The signs make a difference. The 2 has to be positive, and the 15 has to be negative. But it doesn't matter which binomial comes first. So you can write it like this or like that, and you're just fine. Now, do you see how I really used all the same numbers except I just changed this one sign?
Yes.
But it completely changed what you used, didn't it?
Yes.
Okay, now this is the one that I always forget about, 1 times the number. So in this case, we needed to do -1 and -30. And here we have 5 and 6.
It doesn't
So-
matter the order, right? Like if we do like 31st.
It does
That's
not
why it's
matter.
or.
Yeah. Yep. It does not matter which binomial comes first, but what does matter is the sign that's with the numbers. Okay?
This,
Yes.
this is only if the leading coefficient is 1.
Right. This is if the leading coefficient of 1 is 1. But if the leading coefficient is not 1, it's kind of the same idea. So if the leading coefficient is not 1, if we have an A that's not equal to 1, that's a different number, we really kind of think of this as a factor puzzle. It's like a little math puzzle. Yeah. It's along the same idea, but there's a little more thought that has to be put into it. Yes, sir.
Do you know when football players are supposed to go?
2:35.
I know what time this says. No, football players don't have anything to do but sit. The football team is dismissed at 2:50.
Oh,
That's what
And then we start dismissing at 2:55.
okay.
Okay? Alright, so on this one, we're going to look at the first term because it's not 1. Now before we just did x and x because it was just x squared. Or we did y and y because it was y squared. See, y and y. P and p because it was p squared. But this time, it's not just the variable squared, it's 5x squared. So we have to think about how do we get 5?
2.5 times 2.5.
No, 2.5 times 2.5 is 6.
Oh, yeah.
2.5 times 2.
Oh, yeah.
That does work. But we want to factor over the set of integers. So we're only using integer factors. There's only one way to multiply and get 5 with integers.
1 times
5
5.
times 1.
Yes. 5 and 1. Okay. Now, we want to keep this first term positive. So we're going to leave that positive 5x and positive x. Does that make sense?
Yes.
Okay, now luckily for us, our last term, which is the next thing we're going to look at, it is also a prime number. So its only factors are 2 and 1, right? But this is where we get to play. This is where we get to do a little trial and error, where you have to think of it as a puzzle. So I'm multiplying to get a positive 2, but this time I want to add to get a positive 11. And when I put the 2 in, I want to line it up so that if I were to multiply these back, it gets multiplied times the 5. Because 2 times 5 is 10. And then I'm going to put the 1 right here. Because 10 plus 1 is 11. So you kind of have to play with it. You have to use trial and error. You think about what the possible factors are, and then you just kind of move them around until when you do the outer and the inner part of FOIL, when you do this multiplication, you end up with that middle term. Okay. Example 10. There's only one way to multiply and get 3. What is it? 3 and 1. So we're going to do a 3x and a 1x. Now this one's easy and even easier. I don't have to think much. Because there's only one way to get 1.
1 times.
And do you see we're multiplying to get a positive 1? But we're adding to get a negative 4.
So 1 and 1.
Oh wait, no, they both
They
have
both-
to be
They
negative.
both have to be negative. Because that multiplies to give us a positive. And then when we do this negative 3x plus negative 1x, I get negative 4x.
Is that a coincidence that the 2 and the 1 are the 2 numbers that you plug in and that they're equal to the last number of the trinomial?
No, it's not a coincidence. That's part of how you think through the whole process. All right, you try this one, and you're going to have to play around because we're multiplying to get a negative, and we're adding to get a positive. So you have to play with where you put them. Trial and error. Alright, so if we look at number 11, we have 3x as our leading term. So we're going to have a 3x here. 3x squared is our leading term. And an x there. Now, there's really only one way to get 2. It's 2 and 1. But what we have to be careful about is where we place the 2 and where we place the 1. and which one we make positive and which one we make negative. If we put a positive 1 here and a negative 2 there, that gives me a 3x minus 2x, which is 1x. Okay? And that's how this works. So, this is how it works with smaller numbers. Let's look at some bigger numbers. Not huge, but bigger. Alright, so number 12 is 2x squared plus 7x minus 15. Well, the nice part about this one is the 2x squared is pretty simple.
So it's X.
So we have to, the only thing we're going to have to think about is the 15. Because 15 we have some choices. We could do 1 and 15 or we could do 3 and 5. Not a ton. We just have 2 really. Except the sign thing. Alright, so we know it's got to be 2x. And we know it's got to be x. So we want to multiply to get a negative 15. Different signs. Add to get a positive 7. What are you thinking?
3 and 5.
3 and 5 is a good thought.
Yeah, there's 3.
Okay? Because you're very good. If we put the positive 5 here with the x and the negative 3 here, that gives me 10
3.
minus 3.
Yeah.
And that gives us 7.
No, it's like, no, this is right
Oh,
there.
yeah.
Look at this.
You didn't get it. Huh? What you got there? You got a razor?
Alright. Now every time we've had a nice simple prime number here, and this time we have 8. And it's still not hard. It's not like 12
Oh my god.
or 24. Think about all the different ways to multiply and get 24. Alright, so we have 1 and 8, and we have 2 and 4. But if I look at my constant over here, isn't there just one way to do that?
Yes.
1 and 3. Okay, so this time I'm going to start at the back end then. I am multiplying to get a positive 3. But I added something to get a negative number.
What was it?
So they both have to be negative. Good. So we need a negative 1 and a negative 3. So this was easier to deal with this time than the leading one, so I'm going to start here. Now I've got to figure out, is it 1 and 8 or is it 2 and 4? What do y'all think?
I think
2 and 4.
2 and 4.
2 and 4. Okay. So if we put a 2 here and a 4 here, that gives me negative 6x and negative 4x
So that worked
makes
perfect.
negative 10x.
Oh, we only do that.
Try.
Alright, you try. I left you the trickier one because this is negative. That means we got sign issues.
Oh, this is just great. Okay, let's think, shall we?
Oh, can you do that? Okay, I don't think you can do that, Max. You can't make like the 4 or the 2 negative, can you?
Okay, it's not impossible to do, but it's not what you want to do.
Okay.
Yeah, not gonna do this.
Doesn't matter what you do.
Okay, so I'm going to put a 1 here and a 3 here.
I did that. Oh.
Doesn't matter. No,
Okay, so now I have to figure out, will a 1 and an 8 or a 2 and a 4 work for me? Now if I do the 1 here, that gives me 3, and an 8 here, that gives me 8. 3 and 8, whether I add them or subtract them, isn't going to make 10. If I put an 8 here, that gives me 24 and 1. That's not going to give me 10. If I put a 2 here, that'll give me positive or negative 6, and the other one would be the opposite. So I'd have different signs with 6 and 4. But if I put a 4 here, I get 12. And a 2 there gives me 2. So if I make that a negative 12 and a positive 2, does that give me negative 10?
See?
That's what I was asking. That's what I was asking.
I had that, but I had the sign for negative 4.
Okay.
Let's go, man.
Oh, I got
Get
positive.
ready.
Honestly, I did better with these than I was.
Okay. This is my last one.
I always forget there's bigs.
And this one's even more irritating because 6 could be 1 and 6 or 2 and 3. And 8 could be 1 and 8 or 2 and 4. But we know they have to be different signs because we're multiplying to get the negative 8. And we're adding to get negative 13. So you may
Opposite, that's when they're going to be same side.
you may just want to just try something. This is called trial and error. Sometimes you just have to try. All right, if I put an 8 here and a 1 here, that would give me a 6 and an 8. That won't work. If I put the 1 here and an 8 here, that would give me 48 and 1. There's no way to get 13 out of that. So let's try the 2 and the 4. If I put a 2 here and a 4 here, that would give me 24 and 2. That doesn't work. If I put the 4 here and a 2 here, that would give me 12 and 4. Does that give me 13 in any way? Okay, so let's try something different. You want to try 2 and 3?
Yep.
Okay. So let's do 1 and 8 again. If I did the 1 here and the 8 here, that would give me 16
Oh, yes.
and 3.
Yes.
If I made it a negative 16 and a positive 3, does that give me negative 13?
Yes.
And that's what you're doing in your head. What I did out loud is what's going on in your head when you do trial and error. Okay? Now, I goofed on the calendar I printed for you guys. It says it's the textbook. It is not the textbook. It is the workbook, pages 317 and 323. But I did correct the calendar online. And I also sent an email to everyone in my 4th period because I gave them incorrect information. So what was on the calendar I printed for you is incorrect. It is not the textbook. It is the workbook.
Yours this time?